Hi, I'm Teacher Thomas. Welcome to A-Level Maths. This is 9231 Further Mechanics specimen paper for the 2020 exam series question 2. A light elastic string has natural length alpha and modulus of elasticity 24 mg. One end of the string is attached to a fixed point A. The other end of the string is attached to a particle of mass 2m. Requirement A, find in terms of alpha the extension of the string when the particle hangs freely in equilibrium below A. I'll start with a diagram. My string is hanging vertically from point A, and the end has a particle with mass of 2m. I'm looking for the extension per the requirement, so the formula tension equals modulus of elasticity times x, representing the extension, divided by L, which is the natural length. Tension is 2m times gravity, going straight down, equals the modulus of elasticity given as 24 mg times x, that's the extension we're solving for, divided by the natural length of alpha. I can simplify with eliminating m on both sides, g on both sides, and I will cross multiply to 2 alpha equals 24 times the extension, dividing both sides by 24. The extension is alpha over 12. Continuing to requirement B, the particle is released from rest at A. Find in terms of alpha the distance of the particle below A when it first comes to instantaneous rest. I'll use the concept of conservation of energy to note that at point A and then at rest, I'm going to show what my three energies are and then equate the sums of those three energies. Kinetic energy is 0 at the beginning, there's no motion, and at rest, 0, there's no motion. Potential energy, this needs to reference a starting point, so I'm going to call A the starting point where this is my level of 0. The particle will go down, so there will be a decrease in potential energy. That will be negative. I have a mass of 2m times gravity times height, which right now is unknown, so I'm using h. Note that m is the actual given relative to mass for this problem. G is the actual gravity, but h we need to calculate. And for elastic potential energy, we will be starting at 0. And then as a result of the extension, we'll have 1/2 times the modulus of elasticity given as 24 mg times the extension squared. The extension I write as h minus alpha. H is as far down as we go. Part of that is the natural length, which is the alpha, and then beyond that is the extension. So h minus alpha is the extension. And divide by the natural length of alpha. And I'll equate the sums of the energies at A and the energies at rest. The A energies sum to 0 equals the sum of 0 plus negative 2mgh plus 1/2 times 24 is 12. 12 mg times h minus alpha squared over alpha. And now I'll do some algebra. I'll have on the left side 2mgh times alpha equals 12 mg times quantity h minus alpha squared. In this working, I can eliminate m from both sides and g from both sides. And now, thinking about solving for h, I recognize that I'm working with a quadratic. Before that's set up, I'll make one more manipulation. I'll take my 2 and make it 1, take my 12 and make it 6. So I have divided both sides by 2. And so now I'll set up to solve the quadratic. 6 times h minus alpha squared minus, that term on the left simplifies to h alpha. There's an h, there's an alpha, equals 0. From here I expand to 4 terms. 6h squared minus 12 alpha h minus alpha h plus 6 alpha squared equals 0. From here, to find my value for h, I'll use the quadratic formula. I identify 6 as a, minus 12 alpha and minus alpha are both b, and 6 alpha squared, the entire expression, is c. But here I see that my b is negative 13 alpha. So here you should show your working. I won't show the entire procedure. You should show those workings though. What I get to is h equals 13 alpha plus or minus 5 alpha over 12. If I split into 2 discrete values, I end up with the options of 8 over 12 alpha or 18 over 12 alpha. Thinking about the scenario, h is the sum of the natural length of alpha plus an extension. So our result should be greater than alpha. That first answer, 8/12 alpha, is less than alpha. So it must be the second value. And we can simplify 18 over 12 to 3 over 2, and h is 3 over 2 alpha. That is the distance of the particle below a when it first comes to instantaneous rest, and that completes the requirements for part B.